The National Electrical Code (NEC) does not contain specific stipulations exclusively for sump pump installations within 13,800 volt pool wells. However, the NEC establishes comprehensive guidelines for electrical equipment deployed in damp or wet environments, and these provisions are pertinent to sump pump installations in pool wells. These broadly applicable NEC mandates encompass the criteria detailed as follows. Firstly, all electrical apparatus employed must secure listing and approval explicitly for utilization in wet locations. This necessitates verification that the sump pump, associated wiring, and control mechanisms possess certifications attesting to their suitability for functioning reliably and safely amidst moisture or immersion. The identification often manifests as a designation from a nationally recognized testing laboratory like UL or ETL, affirming adherence to stringent safety benchmarks. Secondly, all electrical junctions and terminations must be executed within enclosures engineered to be weatherproof. These enclosures serve to shield connections from water intrusion, thereby mitigating the risks of short circuits, ground faults, and corrosion. The enclosures typically feature gaskets, seals, and robust construction to safeguard the electrical integrity of the system. Thirdly, all wiring must be adequately safeguarded against physical harm. This necessitates protecting conductors from abrasion, impact, and other mechanical stresses that could compromise their insulation or conductivity. Protection methodologies encompass the utilization of conduit, cable trays, or other protective sheathing to ensure the long-term resilience of the wiring infrastructure. Beyond the NEC regulations, supplemental local codes and ordinances could govern the installation of sump pumps within pool wells. These regional or municipal stipulations might impose heightened standards or particular requisites predicated on localized environmental conditions or construction practices. Verifying compliance with these local imperatives constitutes a crucial step in ensuring a legally compliant and secure installation. It is imperative to consult with the local building department or relevant regulatory agency to ascertain the presence of any supplementary mandates that might impact the sump pump installation project. These investigations could unveil specific permit necessities, inspection protocols, or performance criteria tailored to the jurisdictional setting. The term listed in the context of electrical equipment refers to equipment that has been evaluated by a recognized testing laboratory and found to comply with applicable safety standards. The listing mark on a product indicates that it has been tested and certified to meet specific safety requirements, providing assurance that it is safe to use when installed and operated in accordance with the manufacturer's instructions. Weatherproof enclosures are designed to protect electrical components from exposure to the elements, including rain, snow, and ice. These enclosures are typically constructed of durable materials such as metal or plastic and feature gaskets and seals to prevent water from entering. The National Electrical Code serves as the cornerstone for electrical safety standards across the United States. It's a comprehensive document that's regularly updated to address new technologies and evolving safety concerns. While the NEC provides a foundational framework, local jurisdictions often adopt and amend the NEC to suit their specific needs and conditions. This can result in variations in electrical codes from one city or county to another. The NEC guidelines for wet locations are particularly relevant to sump pump installations. These guidelines mandate the use of equipment specifically designed and approved for use in environments where exposure to water is likely. This includes not only the sump pump itself, but also all associated wiring, connectors, and control panels. The requirement for weatherproof enclosures is critical for preventing water from entering electrical connections. Water can cause corrosion, short circuits, and other electrical hazards. Weatherproof enclosures are designed to keep water out, ensuring the safety and reliability of the electrical system. Protecting wiring from physical damage is another essential aspect of electrical safety. Wiring that is exposed to physical damage can become frayed, cracked, or otherwise compromised, increasing the risk of electrical shock or fire. Using conduit or other protective measures can help prevent physical damage to wiring. When installing a sump pump in a pool well, it's important to consider the potential for flooding. This sump pump should be sized appropriately to handle the anticipated volume of water. It's also important to ensure that the sump pump is properly installed and maintained. Regular maintenance can help prevent problems and ensure that the sump pump is working properly. The NEC addresses grounding and bonding requirements, which are vital for electrical safety. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Bonding ensures that all metal parts of the electrical system are connected together, creating a low impedance path for fault current. The NEC covers overcurrent protection, which is designed to protect electrical circuits from damage caused by excessive current flow. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of current when it exceeds a safe level. The NEC includes requirements for wiring methods, which specify the types of wiring that are permitted for different applications. The NEC also covers conductor ampacity, which is the maximum amount of current that a conductor can safely carry. It's important to select conductors with the appropriate ampacity for the intended application. The NEC addresses voltage drop, which is the reduction in voltage that occurs as electricity flows through a conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC contains tables and calculations for determining the appropriate conductor size to minimize voltage drop. The NEC includes requirements for electrical boxes, which are used to enclose electrical connections. Electrical boxes must be sized appropriately for the number of conductors and devices they contain. The NEC covers the installation of lighting fixtures, including requirements for mounting, wiring, and grounding. The NEC addresses the use of flexible cords and cables, which are commonly used to connect portable equipment to electrical outlets. The NEC includes requirements for ground fault circuit interrupters, GFCIs, which are designed to protect people from electrical shock. GFCIs are required in wet locations, such as bathrooms and kitchens. The NEC covers the installation of surge protective devices, SPDs, which are designed to protect electrical equipment from damage caused by voltage surges. The NEC addresses the use of arc fault circuit interrupters, FSIs, which are designed to protect against fires caused by electrical arcs. The NEC includes requirements for the installation of generators, which are used to provide backup power during power outages. The NEC covers the installation of solar photovoltaic PV systems, which are used to generate electricity from sunlight. The NEC addresses the installation of wind turbines, which are used to generate electricity from wind. The NEC includes requirements for the installation of electric vehicle EV charging stations. Always consult the latest edition of the NEC and local codes for the most up-to-date requirements. Proper planning, installation, and maintenance are crucial for ensuring the safety and reliability of electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. The electrician will be able to assess the specific requirements of the installation and ensure that it is performed safely and in accordance with all applicable codes and regulations. When dealing with electricity, safety should always be the top priority. The NEC is a valuable resource for ensuring electrical safety, but it's important to remember that it's not a substitute for common sense and good judgment. Always follow safe work practices and take precautions to avoid electrical shock. If you're not comfortable working with electricity, it's best to leave the work to a qualified electrician. Understanding the basic principles of electricity can help you stay safe around electrical systems. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of current. Ohm's law states that voltage equals current times resistance. Power is the rate at which electrical energy is used. Power is measured in watts. Electrical circuits can be either series or parallel. In a series circuit, the current flows through each component in turn. In a parallel circuit, the current has multiple paths to flow through. Circuit breakers and fuses are used to protect electrical circuits from overcurrent. Ground fault circuit interrupters, GFCIs, are used to protect people from electrical shock. Arc fault circuit interrupters of size are used to protect against fires caused by electrical arcs. Surge protective devices, SPDs, are used to protect electrical equipment from damage caused by voltage surges. Static electricity is a buildup of electrical charge on a surface. Static electricity can cause shocks and can damage electronic equipment. Lightning is a powerful discharge of static electricity. Lightning can cause fires and can damage electrical equipment. Electrical safety is everyone's responsibility. By following safe work practices and taking precautions to avoid electrical shock, you can help prevent electrical accidents. When dealing with a 13,800 volt system, the requirements are much more stringent and require specialized knowledge and equipment. Firstly, only qualified personnel should work on such systems, meaning individuals with specific training and certifications for high voltage work. Secondly, personal protective equipment (PPE) is essential, including but not limited to insulated gloves, sleeves, and appropriate clothing designed to protect against high voltage exposure. Thirdly, adherence to lockout/tagout procedures is critical to ensure the system is de-energized and cannot be accidentally re-energized while work is being performed. Fourthly, maintaining safe clearance distances from energized parts is a must to prevent arc flash or direct contact, and these distances are specified in safety standards and regulations. Fifthly, grounding practices are paramount, ensuring proper grounding of equipment and the system to minimize the risk of electric shock. Sixthly, regular inspections and maintenance of the electrical system and equipment are necessary to identify and address potential hazards. Seventhly, employing appropriate tools and equipment rated for the voltage level is crucial, including insulated tools and testing equipment. Eighthly, comprehensive training and education on high voltage safety practices are vital for all personnel working on or near the system. Ninthly, the development and implementation of an emergency response plan are essential, outlining procedures for handling electrical incidents or accidents. Tenthly, compliance with all applicable codes, standards, and regulations, including the National Electrical Code (NEC) and any local requirements, is mandatory. These measures are in place to safeguard individuals and prevent electrical accidents when working with high voltage systems. The sump pump itself, while not directly part of the 13,800 volt system, needs to be installed with consideration of its proximity and potential interaction with the high voltage environment. This includes ensuring proper grounding, using appropriate wiring methods, and providing adequate physical protection. The control system for the sump pump should also be designed with safety in mind, incorporating features such as overcurrent protection, current fault protection, and a disconnect switch for maintenance purposes. The specific type of enclosure used for the electrical connection should be chosen based on the environment and the potential for exposure to water, dust, or other contaminants. Weatherproof enclosures are a common choice for outdoor or wet locations. The wiring methods used should be appropriate for the voltage and current requirements of the sump pump, as well as the environment in which it is installed. Conduit is often used to protect wiring from physical damage and moisture. The grounding system should be designed to provide a low impedance path for fault current to flow back to the source, minimizing the risk of electric shock. Grounding electrodes should be properly installed and connected to the electrical system. Overcurrent protection devices, such as circuit breakers and fuses, should be sized appropriately to protect the wiring and equipment from damage caused by excessive current flow. Ground fault protection devices, such as GFCIs, should be installed in wet locations to protect people from electrical shock. A disconnect switch should be provided to allow for safe maintenance and repair of the sump pump. The disconnect switch should be readily accessible and clearly labeled. Regular inspections and maintenance should be performed to ensure that the sump pump and its electrical system are operating safely and effectively. Any problems or potential hazards should be addressed promptly. The NEC provides detailed requirements for electrical installations in various types of locations, including wet locations, hazardous locations, and healthcare facilities. These requirements are designed to protect people and property from electrical hazards. It's important to consult the NEC and other applicable codes and standards when designing and installing electrical systems. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. The electrician will be able to assess the specific requirements of the installation and ensure that it is performed safely and in accordance with all applicable codes and regulations. When dealing with electricity, safety should always be the top priority.